Hello, I'm Seokjin Kim. This is first oral presentation of Advanced Topics in Physics 2 lecture. The content is related to my research project, the diode pumped alkaline laser. The outline. At previous experiment, I will explain about advantages of diode pumped alkaline laser and previous researches. Second, I will mention the difference of my setup comparing with previous researches. Third, potential of my research. Fourth, schematic diagram that I will do. Fifth, research results of experiment and perspectives. Finally, conclusion and summary. First, previous experiments. For decades, there were many researches on alkaline lasers. There are advantages of alkaline lasers comparing to other lasers. High efficiency, gas medium, narrow line width, and RF water absorption spectrum. First of all, the alkaline atoms have highest quantum efficiency at present. The quantum efficiency is theoretically highest efficiency of laser. Helium-neon laser have 4.3%, carbon dioxide laser have 43%, and anti-arc laser have 76% of quantum efficiency. Also, ytterbium fiber laser have almost 89% of quantum efficiency. However, alkaline atoms have over 95% of quantum efficiency. An alkaline laser has narrow line width. For example, erbium doped fiber laser have almost terahertz line width, and anti-arc laser have hundreds of gigahertz, 119 gigahertz. The alkaline laser have tens of gigahertz line width, and this is broadened by collisional broadening of buffer gas. In addition, there is thermal problem as solid-state laser. Like small effect, as laser power increases, the solid is heated and beam quality is decreased. Since the alkaline vapor laser is gas medium, it has advantages at thermal problem. Also, from 800 to 900 nanometers of lasing wavelengths of diode pumped alkaline laser is out of water absorption spectrum. This means that alkaline lasers are good to use free space communications. As I mentioned before, there were many researches on alkaline laser. Sky blue laws are research of diode pumped alkaline lasers, and green laws are using other lasers as a pump source. The most important parameters for these researches are optical efficiency and slow efficiency. Optical efficiency is outpower over pump power, and slope efficiency is slope of up power versus pump power. However, sky-blue laws does not match the pump size and cavity mode size. Some of them, the cavity mode, are inside the pump size. However, they does not match all over the game medium. For better explanation, previous researches makes pump beam focus on the center of game medium. Some of them are smaller than the cavity mode, and some of them larger than the game medium. These force maximum are waste of beam size. For my research, I will use fiber to deliver the pump beam power. By passing the single mode or large mode area single mode fiber, only Gaussian beam survives. As a result, we could obtain the Gaussian pump beam distribution, intensity distribution, which is same intensity distribution at Eigen mode inside the cavity. Second, I will match the pump beam size and cavity Eigen mode size. The potential of my research is high efficiency. The left paper is ytterbium doped large core fiber laser paper with 1.36 kilowatts. At this paper, the researcher group obtained 75% of optical efficiency. However, the world record of cesium laser is only 64%, despite the higher quantum efficiency. In my opinion, this is because the pump beam does not match it with cavity mode. As a result, by my experiment, I expect more high efficient laser, the cesium laser, could be obtained. Also, these high efficiency gas medium laser could be used as direct energy weapon. Already, USA developing the diode pumped alkali laser as a weapon purpose. The schematic diagram of my research. I will measure the problems of previous cesium laser works of our laboratory by measuring the cavity size and actual pump beam profile. And I will do a simulation to confirm whether the efficiency will increase or not by changing the pump source, lens position, and the whole cavity position. If the optical to optical efficiency increase in simulation, I will do an experiment. I already measured the observation efficiency of previous our laboratory works. The 67% of observation efficiency means only 67% of pump power is engaged in laser operation. Now, I do simulation with pump beam distribution and lens position and whole cavity composition. And the result will be iteration versus laser power versus iteration, and for lens position and pump size and cavity composition, and then laser power. After the simulation, I will do experiments. For summary, the purpose of my research is trying to achieving high efficiency section laser by maximizing overlapping the pump and cavity mode. The motivation is that the previous experiments focused the pump beam at middle of the gain medium, and they does not match the pump size and cavity mode size. I will do a simulation with virtual fusion Foxley algorithm. I will change the lens position and pump source distribution. And I will try to figure out whether large power than previous paper exists or not. And then I will do experiments with fiber pump beam deliver setup with changing lens. From the SMF or large model area SMF, we could obtain about 1 M² pump source, and we could maximizing the overlapping of pump intensity distribution and cavity Eisen mode. This is the end of my presentation. Thank you for watching.